In the tiny world of quantum physics, things get pretty incredible compared to what we're used to in everyday life. One of these strange phenomena is called quantum superposition. This video will explore the enigma of superposition, looking at its basic ideas, how scientists have proven it in experiments, and the implications it has on how we view reality. Quantum superposition is a rule in quantum mechanics that says tiny particles, like electrons and photons, can be in multiple definite states at one time. This concept violates our perspective on physics, because everyday things can only demonstrate one definite state at a time. For example, someone spinning a ball on their finger can only spin the ball left or right due to our laws of physics. However, when you go down to the quantum level, many of these laws are no longer present. For some reason, electrons and photons can perform those same motions of left and right, but at the same time. This principle also delves into the fact that these particles suspiciously conform to one definite state, but only while being observed. The concept of superposition mainly started from a thought experiment called Schrödinger's, created by Erwin Schrödinger in the year 1935. The idea demonstrates how superposition would work. It could occur on our larger, non-quantum scale. The idea generally goes that a cat is placed in a box with a vial of poisonous gas, a Geiger counter, and a mallet connected to the Geiger counter in the box with the cat. If the Geiger counter detects the decay of a specific radioactive particle, the mallet will smash the poison vial, thus killing the cat. Now, to our basic understanding of reality, the scenario could essentially be chalked up to the cat having a 50/50th chance of being dead or alive, much like a sick version of flipping a coin. Instead, quantum superposition throws the concept of either or out the window. And rather, if this experiment took place in the quantum world, the cat would both be dead and alive at the same time, until the box is lifted and the cat is observed. I know this concept probably sounds like nonsense. To that I say, shut your filthy mouth. What I meant to say was plenty of scientists felt the same way, that us, until the double-slit experiment. This experiment is a classic in physics that helps us understand the strange behavior of particles, like electrons and photons. Let me break it down. Imagine you have a tiny gun that shoots really tiny particles, like marbles, one at a time. You aim these particles at a barrier with two slits now. You might expect the particles to go through one slit or the other, creating two lines on a screen behind the barrier. But here's the strange part. When you shoot these tiny particles, the screen displays several bright and dark lines on the screen, similar to the effect waves would have as opposed to marbles. Waves have peaks and valleys, and when the waves from the two slits meet, they can either add up making a big peak or cancel out making nothing. This creates a pattern of alternating bright and dark stripes on the screen. Now, here's where it gets weirder. When scientists check which slit each particle goes through, the particles suddenly act like marbles again. The pattern on the screen changes from stripes to just two lines, like marbles would make. This experiment ultimately shows that quantum superposition exists due to the fact that particles behave like both waves and marbles. They create patterns on a screen that show they're in more than one place, but when we look at them, they pick just one place to be. It's like they know they're being watched. Superposition challenges our normal ideas about how things work. When we look at these tiny particles, they stop being in many states and choose just one. This makes us wonder about the role of our consciousness in shaping what we see, and the potential uses of superposition in the future. Many people, including myself, believe there are actually several other universes out there, or the multiverse theory. One of these multiple theories is the many worlds interpretation, which stems from the existence of superposition. This idea suggests that when a particle is in a superposition, all the possible outcomes actually happen in separate, non-communicating branches of the universe. It's like the universe splits into different versions of itself, each containing one of the possible states the particle could be in. The many worlds interpretations suggest the reason particles in superposition conform when we view them is because the multiple states they were in split off into different universes. If this is really how superposition works, that most likely means every possible outcome of a situation happens, but in different universes. It's like a grand-scale quantum telltale game, except each choice just creates a new universe entirely. Now let's discuss quantum computing. Superposition is not just a strange idea. It has served to be a major technological advancement. For example, quantum computers have been designed using this very principle. Normal computers stores data and instructions using bits expressed through the numbers 1 or 0, meaning only one operation can be performed at a time. However, quantum computers utilize tiny bits called key bits that can be both 0 and 1 at the same time. This allows them to solve certain problems and process much faster than regular computers and even the fastest supercomputers. These computers still have a few problems, such as the conditions they need to be kept in, weakness to interference, and their threat to national security, but their potential is overall very promising. Quantum superposition may sound like science fiction, but it's a real and mind-bending part of the quantum world. From the curious cat in a box to the powerful potential of quantum computers, exploring superposition challenges how we see the world around us. As scientists keep exploring this tiny realm, the mysteries of superposition guide us toward a deeper understanding of the quantum building blocks that make up our universe. Well, that's enough learning for today. Thank you and goodbye.